All right, let's dive into some cutting-edge AI research.
Oh, good.
Today, we're taking a deep dive into self-adaptive large language models, or LLMs for short.
LLMs?
You've been digging into this fascinating world of AI, and by the end of this deep dive, you'll understand how this technology could totally change the way you think about AI
Totally,
and
yeah.
interact with AI, unlocking a whole world of possibilities.
Yeah, what's really exciting here is this idea of LLMs that can adapt to new tasks on the fly.
Okay.
Think of it like having a Swiss Army knife of AI
Okay.
that can handle anything you throw at it.
That's a great way to put it.
Yeah.
So the research paper we're looking at is called Transformer² Self-Adaptive LLMs.
Okay.
And it's all about a new framework that could make this Swiss Army knife AI a reality.
Right.
The researchers at Sakana AI were even cool enough to open source the code.
Nice.
So anyone can actually tinker with this technology themselves.
Yeah, that's awesome.
Pretty cool, huh?
It's a game changer because this paper tackles a huge problem with traditional AI training. It's like teaching an old dog new tricks, right?
Right.
Time-consuming, resource-intensive,
Yeah,
and often the AI ends up forgetting old tricks as it learns new ones.
totally. Like, if you wanted to teach an AI to translate from Spanish to French,
Right.
you'd have to basically retrain the entire model from scratch.
Yeah,
But this paper suggests a different approach.
exactly. And the paper lays out why the old way of doing things, traditional fine-tuning,
Yeah.
just doesn't cut it anymore.
Okay.
It's not just the resource intensity.
Right.
It's also that models tend to overfit,
Hmm.
meaning they get too specialized to the training data.
Okay.
I don't generalize well,
So they basically become one-trick ponies.
pretty much.
Okay.
And then there's the issue of task interference.
Uh-huh.
This is where learning a new task can actually mess up the model's performance on something it already knew how to do.
Gotcha.
Like the AI gets confused and starts mixing up its skills.
Okay, I see the problem.
Yeah.
So how does Transformer² fix this?
Well, at its core, Transformer² is a two-pass mechanism.
Okay.
First, it analyzes the task at hand,
Right.
figures out what's unique about it,
Okay.
and then activates specific expert vectors for that task.
Wait, expert factors, what are those?
Think of them like specialized modules within the AI,
Okay.
each trained to handle a particular type of task.
Gotcha.
And these experts have been trained using reinforcement learning,
Uh-huh.
which is like giving the AI a reward when it successfully completes a task.
Interesting. So it's not just predicting the next word in a sentence.
Right.
It's actually learning to solve problems and get rewarded for it.
You got it.
Okay.
And the really cool part is that these experts are then dynamically combined to fine-tune the model for that specific task.
So it's like the AI is assembling a team of specialists to tackle each new challenge.
Exactly.
I like that analogy.
Now, to understand how this works, we need to dive into the heart of this innovation,
Okay.
singular value fine-tuning, or SVF. This method is all about tweaking specific values within the model's weight matrices.
Okay, hold on. For those of us who aren't AI engineers,
Sure.
can you break down what SVF is and why it's such a big deal?
Of course. Imagine a massive soundboard with tons of sliders,
Yeah.
each controlling a different aspect of the AI's knowledge.
Okay.
SVF is like having a master control for each category of sounds.
Mhm.
Language, math, logic,
Right.
allowing you to boost or lower entire groups without adjusting each tiny slider individually.
So instead of rewiring the entire soundboard every time you want to create a new sound,
Right.
you have these master controls that let you easily adjust the overall mix.
Precisely.
Okay.
And this approach has some major advantages.
Like what?
First, it's super efficient.
Okay.
You're only tweaking a few key parameters rather than retraining the entire model.
So it's like finding a shortcut to fine-tuning the AI.
Exactly.
What else is great about it?
Well, it's also highly compositional, which means you can combine these tuned values in different ways to get different results. It's like having a set of pre-trained skills that the model can mix and match depending on the task.
So it's flexible and adaptable. I like it.
Yeah.
What else?
And there's another crucial advantage.
Okay.
SVF has built-in regularization,
Uh-huh.
which helps prevent the model from overfitting,
Okay.
especially when you're working with smaller data sets.
Gotcha.
It's like teaching the AI to be more careful and avoid jumping to conclusions too quickly.
So it's more reliable and less prone to making silly mistakes.
Exactly.
Okay, so we've got these expert vectors trained with reinforcement learning
Right.
and this super efficient SVF method.
Yeah.
How do they all come together in Transformer²?
Well, The paper outlines 3 self-adaptation strategies that Transformer² uses to put those SVF experts to work.
Okay.
The first one is prompt engineering.
Prompt engineering, that sounds familiar.
Right. It's a common technique in AI.
Right.
In this case, Transformer² uses the prompt or the input given to the AI
Uh-huh.
to figure out what kind of task it's dealing with.
Okay.
It's like the model is asking itself, what am I being asked to do?
Right.
And then calling in the appropriate expert based on the answer.
So it's a simple way to activate the right skills for the job.
Right.
What are the other strategies? Okay, so prompt engineering is like a first-line triage.
Right.
But what about more complex tasks?
That's where the second strategy comes in.
Okay.
The classification expert.
Mm.
Instead of relying on just the prompt,
Right.
Transformer² actually has a dedicated expert that's been trained to analyze and classify tasks
Okay.
with more nuance.
So it's like having a specialist whose only job is to figure out what the AI needs to do.
Right.
That's pretty clever.
It is, and this classification expert uses SVF
Okay.
to fine-tune its understanding,
Right.
making it incredibly efficient and accurate.
Gotcha. So what's the third one?
But perhaps the most exciting strategy is the third one,
Okay.
few-shot adaptation.
Few-shot adaptation.
Yeah.
I think I've heard of few-shot learning, but how is that used for adaptation?
Well, few-shot learning is all about training AI models with just a handful of examples.
Right.
Transformer² takes this concept a step further by using those few examples to create a brand new SVF expert vector,
Oh.
tailored specifically to the task at hand.
So it's like showing the AI a couple of examples
Right.
and saying, see, this is what I need you to do. Now go figure out how to combine your skills to make it happen.
You got it.
Okay.
And the results are really impressive
Oh, wow.
across a variety of tasks and language models,
Okay.
like Llama and Mistral.
Uh-huh.
This few-shot adaptation strategy showed the most promise.
It seems like it's taking that Swiss Army knife analogy to the next level.
Yeah.
The AI isn't just switching between tools.
Right.
It's actually building new tools on the fly based on what you need.
Exactly. Now, speaking of Llama and Mistral,
Yeah.
there's another fascinating finding in this paper.
What?
Positive transfer
Mm.
between different LLMs using those SVF vectors.
Wait, so knowledge learned by one model can be transferred to another,
Yes.
even if they have different architectures?
Yeah.
That seems like a big deal.
It is. It opens up all sorts of possibilities.
Right.
Imagine being able to recycle knowledge from smaller models to larger ones,
Yeah.
making those more advanced AI systems more accessible.
I can see how that would be a game changer for AI development.
Right.
But I do wonder if the models are very different.
Yeah.
Wouldn't there be some limitations to how much knowledge can actually be transferred?
That's a great question.
Yeah.
And the paper does acknowledge that this is an area that needs further investigation.
Okay.
They mainly focused on transfer between models with similar architectures.
Okay.
But it definitely raises some interesting questions about the limits and possibilities of knowledge transfer in AI.
It's like trying to teach a student advanced calculus before they've even learned algebra.
Right?
There might be some fundamental gaps that prevent effective learning.
Exactly. But even if transfer is possible,
Yeah.
you also have to consider how to make sure the smaller model
Right.
doesn't lose its own unique capabilities in the process.
Yeah.
It's a delicate balance between acquiring new knowledge
Mhm.
and preserving existing expertise.
It's like trying to integrate a new organ into a body.
Yeah.
You want it to function seamlessly without disrupting the other organs and systems.
Right.
Okay, so we've covered a lot of ground here.
Yeah.
We've talked about the limitations of traditional fine-tuning,
Right.
the innovative approach of Transformer²
Right.
with its SVF method and those 3 self-adaptation strategies,
Right.
and the exciting potential of knowledge transfer between models.
Yes.
But before we wrap up,
Yeah.
I'm curious to hear your thoughts on the PCA analysis that the researchers conducted.
Yes, that's a really intriguing part of the paper.
Okay.
The PCA analysis looks at the model's weight matrices and reveals some important insights about where the most crucial information is stored.
Okay.
What's interesting is that traditional methods like LoRa-XS,
Yeah.
which try to capture the top components of these weight matrices,
Yeah.
might actually be missing out on some valuable information.
So it's like assuming that the loudest voices in a crowd are the only ones worth listening to.
Right.
When in reality, sometimes the quietest whispers hold the most profound truths.
Precisely.
I like that.
And this finding, coupled with the success of SVF,
Yeah.
really challenges us to rethink how we approach AI development.
Okay.
Are we too focused on building bigger and more complex models,
Mm.
when perhaps we should be focusing on understanding the nuances and intricacies of the models we already have?
It's a good reminder that sometimes the most elegant and effective solutions
Right.
are also the simplest.
Exactly. And that brings us back to the core of what Transformer 2 is all about.
Okay, let's zoom out for a second.
Sure.
For someone like me who's trying to stay ahead of the curve in AI,
Yeah.
what's the big takeaway from all of this?
Well, I think the most important takeaway is that we're seeing a shift towards
Okay.
more dynamic and adaptable AI systems. Transformer 2, with its innovative SVF method and self-adaptation strategies,
Yeah.
is a perfect example of this trend.
So it's not just about building bigger models anymore. It's
Mm.
about building smarter, more flexible AI
Yeah,
that can learn and adapt in real time.
exactly. And as you continue to explore this field,
Right.
keep this principle in mind.
Okay.
The future of AI lies in systems that can continuously evolve and refine their skills,
Uh-huh.
becoming more versatile and helpful over time.
It's like the difference between a static encyclopedia and a constantly updating online knowledge base.
Yeah.
The static one might hold a lot of information, but
Right.
the dynamic one is always evolving and staying relevant.
That's a great analogy.
Thanks.
And just like an online knowledge base relies on efficient algorithms
Right.
to organize and retrieve information,
Okay.
so too will future AI systems
Yeah.
need to develop sophisticated ways to manage and integrate knowledge.
So this research isn't just about a specific technology. It's about a fundamental shift in how we approach AI development,
Yeah.
moving towards more dynamic, self-organizing systems.
You got it. And that's a powerful takeaway for anyone who's interested in the future of AI.
Right.
Now, before we move on, there's one more point I'd like to highlight.
I'm all ears.
Oh, yeah.
What else caught your attention?
The paper briefly touches on the potential of SVF for continual learning,
Okay.
and I think this is an area that deserves a closer look.
Mm-hmm.
See, continual learning is all about teaching AI to learn new things without forgetting what it already knows.
Yeah, that's a classic problem in AI, right?
Yeah.
Like if you teach an AI to play chess, it might suddenly forget how to play checkers
Exactly.
because the new knowledge overwrites the old.
Right. But what's really exciting about SVF
Yeah.
is that it uses these separate expert vectors to represent different skills.
Okay.
Think of it like having a mental filing cabinet where each drawer holds a different type of knowledge.
Okay.
This makes it much easier to learn new things without disrupting the existing structure.
So instead of just dumping everything into one giant mental pile,
Right.
the AI can neatly organize its knowledge and skills.
Precisely.
That seems like a much more efficient way to learn.
And if we combine this modular approach with reinforcement learning techniques
Yeah.
that specifically reward the AI for retaining old skills while learning new ones,
Mm-hmm.
we could potentially overcome this challenge of catastrophic forgetting.
Wow. So we could create AI that's not just adaptable,
Right.
but also capable of lifelong learning.
It would.
That would be incredible.
Imagine the possibilities for AI applications that require continuous learning and adaptation,
Okay.
like personalized education or healthcare.
Right.
You could have AI tutors that adjust to each student's learning style,
Uh-huh.
or AI-powered medical devices that constantly update their knowledge based on the latest research.
That sounds like it's straight out of science fiction.
I know.
But even if we're not quite there yet,
Yeah.
it's exciting to see this kind of progress being made.
Absolutely, and it's important to remember that we're still in the early stages of exploring these concepts.
Yeah.
Transformer 2 and SVF are just the beginning.
Okay.
There's so much more to discover and invent
Mhm.
in this field of self-adaptive and continually learning AI.
And the coolest part is that you don't need to be an AI researcher at a big tech company to get involved.
Right.
The code for Transformer 2 is open source.
Exactly.
Which means anyone can dive in and experiment with this cutting-edge technology.
Yeah.
So for you listening, if you're fascinated by AI and want to explore this groundbreaking research firsthand,
Yes.
check out the Transformer 2 paper and the open source code.
Please do.
You might just be the one to make the next big breakthrough.
And remember, what we've discussed today is just a glimpse into the world of self-adaptive LLMs.
Right.
There's so much more to uncover and so many exciting possibilities to explore.
Well, that's a great note to end on.
Yeah.
Keep exploring, keep learning, and who knows, maybe you'll be the one to shape the future of AI.
I hope so.
Until next time.